This is a video for MEI Core Pure Mathematics, Vectors 5, Further Lines and Planes, 5.2, using the vector product. We've already seen that the vector product is another vector in 3 dimensions. And this vector is perpendicular to both of the vectors that we started with. This turns out to be extremely useful and important in doing further work relating to vectors. We have A cross B equals n, where n is some vector which is perpendicular to both A and B. If you look at this diagram here, I've got A and B and n is perpendicular to B and perpendicular to A. A, B and n form what's called a right-handed system. If you think about A and B as lying in a plane, then as you move from A to B, remember it's A cross B that we're doing. If you imagine that this is a spiral like a screw, then this direction is anti-clockwise and therefore it would be coming out of the plane, coming upwards. And that's our right-handed system. There's an alternative form for A cross B, and it's down here. A cross B can also be written as mod A mod B times the sine of the angle between them times a unit vector which is perpendicular to both A and B, and we use this hat notation here to indicate a unit vector in the direction of n. Now this is another form that allows us to relate the magnitude of the vector and the angle between them, and we've seen a similar form with A dot B equals AB cos theta. We know that A dot B equals 0 means that the two vectors are perpendicular. What does A cross B equals 0 mean? And you might want to think about that. So because the cross product gives us a vector which is perpendicular to the two vectors we started with, we can use this to find a vector that is perpendicular to these two, for instance. If I call those vectors A and B, then if you imagine A and B lying in a plane and they're forming a right-handed system, then A cross B, which will go in that direction, will be spiraling out of the plane this way. So there's A cross B. And B cross A will spiral into the plane down that direction. So let's have a look at A cross B from this example. That's 1 minus 1, 3, cross 2 minus 1, 2. And I'll get, well, for the top component, I'll get minus 2, take away minus 3. So that's minus 2 plus 3. For the middle component, I'll get 6, take away 2. Bottom component, I'll get minus 1. Take away minus 2, so that's plus 2. So I will end up with 1, 4, 1. Now we can use this idea to find the plane through 3 points. If you imagine that we've got a plane, and I've got 3 points on that plane, A, B, and C, then I can pick one point, I'm going to pick A, and form the two vectors AB and AC. And because all 3 points lie in the plane, those two vectors must lie in the plane. And if I can now find a vector which is perpendicular to both of those, then that will give me the normal vector to this plane. So if I look at AB first of all, 3 minus 1, 1, minus 1 minus 2, 0. And that's 2, 1, 1. AC is 1, 2, minus 2, minus 1, minus 2, 0. And that's 0, 4 and minus 2. So AB cross AC is 2, 1, 1 cross 0, 4, minus 2. And you could at this point use your calculator to work that out. I'm going to do it by hand, so we're going to get minus 2 take away 4 is minus 6. And we'll get nothing take away minus 4 is 4. And we'll get 8 take away nothing is 8. So that's my cross product. But I could use minus 3, 2, 4, which is parallel to that and would still be a normal vector of the plane. And it's a good idea to effectively cancel this down as much as you can so that you get the simplest version of the normal vector. And now to form the plane, I want r dot n is equal to some point on the plane. I'm going to use A again, dot n. So this gives me r dot minus 3, 2, 4 is equal to, and A is 1, minus 2, 0, dot minus 3, 2, 4. And that gives me minus 3, take away 4, plus nothing, that gives me minus 7. And so my vector equation for this plane is r dot minus 3, 2, 4 is equal to minus 7. There's that written up a little bit more neatly for you to follow. There's the confirmation that AB is 2, 1, 1 and AC is this. Here's the cross product, and it's been cancelled down effectively. It's been simplified to give me this version for the normal vector, and hence we get this for the equation of the plane. So to summarize this then, if we want to find perpendicular vectors for these two, let's call these A and B. And it doesn't matter if we do A cross B, so we end up with this result, or whether we do B cross A and we end up with this result, we get a vector which is perpendicular to the other two vectors. If you're struggling to see the three-dimensional vectors, let's just have a look at this plot. This has got A is 1, 0, minus 4, and B is 1, 2, minus 1, as we have in our example. And the red vector here is A cross B, and the blue vector here is B cross A. And you can see that these are in the opposite direction. And if I just nudge these round a little bit, you can see what I mean by the right-handed system. So if we're looking down on this red vector from above, then this anti-clockwise direction would effectively unscrew up the red vector. And similarly, B to A, which is in a clockwise direction, would effectively screw down into the plane. The next video in this sequence is 5.3, the perpendicular distance from a point to a plane.